Now I'll show you the waveforms of all 6 trigonometric ratios. This is GeoGebra app. Okay. Now I'm going to show the sine wave. Look at this. This is the sine wave. This app will be very interesting to use. Here I'll change the outputs, I mean input let us give a degree, that is okay, pi by 2 radians will give, that is scale value. Here automatic it has setted. Let us change this to, here 1 unit they have given, let us change as pi by 2. 1 unit in x value will change as pi by 2, and in y axis let it be 1 unit is equal to 1. Now look at this, how it has changed. This is the sine wave. I told you sine wave is the increasing wave. Okay, and I'll add the input also. Special points will add. It will be very nice to use, but you should learn you should practice of using this, then only it will be easy. You can also add the inputs. 1 minute. Okay, look at this. First sine 0. For sine 0 the wave is starting. Next gradually it is increasing. When it is sine pi by 2, sine is reaching to 1. Again it will decrease. Like this is a sine wave. Next I'll show you the cos waves. Cos, add the input, that is x will be theta value whatever given. Look at this now. Both I added here. Wait a minute. Now see, I have added the inputs, that is x value as pi have given x value as 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, that is like pi by 6, pi by 4, pi by 3, pi by 2, like that I have given. And you can see the outputs also here. Look at this. This is a cos wave. Cos 0, 0, cos 30 degree, root 3 by 2. Root 3 by 2 will be approximately 1.732. Sorry, it is this is increasing function. This is sine wave. Sine 0, 0, sine 30 degree 1 by 2.5. Next sine 45 degree 1 by root 2. 1 by root 2 will be approximately 1.4. Next sine 60 degree root 3 by 2, approximately 0. Root 3 by 2 approximately 0.8, like 0, 0.5, 0.7, 0.8, next one, sine 90 is 1. Now I'll change to cos wave. Yes, look at this. Cos wave is decreasing wave. Cos 0, 1, next cos 30 degree is 0.8, that is root 3 by 2. Next cos 45 degree 1 by root 2, it is 0.7. Next is cos 60 degree, it is 1 by 2.5. Next cos 90 is 0. And also I have given here what is cos pi, that is cos 180 is minus 1, it is touching minus 1 point. Again, what is cos 360? 360 also I have given, again it is reaching to 1. Like that, the cos wave will be between 1 from 1 to minus 1. Whatever inputs you will change, the waves will be 1 to minus 1. Clearly we can understand this. Cos will not cross beyond 1 or beyond minus 1. It will be from minus 1 to minus 1. Whatever inputs you will give, waves will get like this only. Next is, I'll change to tan. Tan x, that is x in place of x value. I can give anything except, you will not accept odd multiples of pi by 2. Input can be any real numbers except the odd multiples of pi by 2. This is a tan wave. Look at this. Let's look at this. Tan 0, 0. Tan 30 degree 1 by root 3, that is 0.5. Next tan 45 degree 1. See, it is touching 1. Next is tan 60 degree root 3, that is 1.73. Little bit it will be keeping on increasing if you change. You can give any inputs except, see, look at this x-axis. Input should not be the odd multiples of pi by 2. That is, see here, waves is present only in 0, pi, 2 pi, 3 pi. It is not present in pi by 2, 3 pi by 2, 5 by 2. That's why input cannot be odd multiples of pi by 2. That is all real numbers except 2n plus 1 pi by 2. Output can be anything, but look at this wave. It is not touching that next line. Wave is increasing from 0, but it is not touching pi by 2. So it will not reach there. So it is for all real numbers in between minus infinity to infinity. Output is any real numbers you will get, but it is not minus infinity and plus infinity. Next we will change to tan. Tan already done. Cot now. Cot x. Yes, just it is like a mirror image of tan. Look at this. For cot, you can give any inputs, but except even multiple of pi. See, the wave is not present in 0, pi, 2 pi, 3 pi. And output is any real numbers except minus infinity and infinity. In between minus infinity to infinity. This is cot wave. Next is, I'll show you cosecant. Cosecant and cot are friends, no? Inputs are same for cosecant and cot, but outputs are different. You will get surprised if you see the cosecant wave. I've given the inputs. See, cosecant graph will be like this. This is cosecant wave. Cosecant 0, it is not defined, no. So at the origin you will not get the graph. Graph will not touch the origin. From cos 30 degree you will get cos 30 degree is 2 point have marked here, and cos 45 degree root 2. Root 2 is what? 1.414. Next is cos 60 degree 2 by root 3. 2 by root 3 is 1.15, around that. So it is little bit more than 1. Next is cos 91. Exactly it is touching 1. Again the wave started increasing, but it will not touch because input cannot be given at pi, no. So it will not touch that pi line. So input cannot be in the even multiples of pi. So wave is absent in pi, 2 pi, 3 pi. Wave will be present only in pi by 2, 3 pi by 2, 5 pi by 2. Negative also will get. Look at this. 270 degree. Cosecant 270 degree is minus 1. So it is touching minus 1. That is 270 means 3 pi by 2. Cosecant 3 pi by 2 is minus 1. Next, we'll see the secant wave. Same like this only will get. Same like cosecant theta will get. But inputs will be similar to tan. Tan input and secant input will be same. Its output will be related to same like cosecant. See here, see this secant 0. Secant 0 is 1. So the wave is starting from 1. Next it will gradually increase, but it will not touch pi by 2 because input cannot be the odd multiples of pi by 2. Wave is absent in pi by 2, 3 pi by 2, 5 pi by 2, so on. Very interesting, no? Yes, trigonometry have great uses in scientific researching field and so on. Okay, use GeoGebra app and learn how this input and output changes and enjoy the max. Thank you.